What is an equivalence relation really? This idea comes up in mathematics all the time, so I wanted to give some intuition and some examples to help us understand it better. Most textbooks will start out by explaining what a relation is, which is something that relates elements of a set, like the less than symbol, the equal symbol, and more generally, we'll just use this sort of squiggle to denote a relation. A relation is an equivalence relation if it satisfies three properties: reflexivity, where every element is related to itself; symmetry, where if x is related to y, then y is related to x; and transitivity, where if x is related to y and y is related to z, then x is related to z. I actually think it's more helpful to think of equivalence relations as partitioning a set. So let's say I have some candy here, and I want to somehow sort it. There are lots of ways I could do this, but here I'm going to sort it by color. So I'll put all the red ones in a pile, all the green ones in a pile, and so on. This defines a partition on the set. So here I defined an equivalence relation of having the same color and put everything related into a pile together. And what I mean by a partition here is that each of these piles is a disjoint pile, and I'm going to call it an equivalence class. And every element has exactly one equivalence class. So there are no classes with nothing and no classes that overlap. And elements in the same class are equivalent. Sort of the classic example that people give when talking about equivalence relations is modular arithmetic. So thinking about the integers mod 3, for example, when I say mod 3, I mean when we divide by 3, this is the remainder we're left with. So thinking about things mod 3, there are only three options here. When you divide by 3, you can have a remainder of 0, 1, or 2. And what we can do is we can make these our equivalence classes and we can start labeling stuff. So on our number line, we have 0, 3, 6, and so on that all are divisible by 3, so they have a remainder of 0 when divided by 3. We have numbers like 4 and 7 and 1 that give a remainder of 1 when they're divided by 3. And finally, we have numbers like 2, 5, and 8, where when we divide them by 3, we are left with a remainder of 2. So we end up with this cool thing where it sort of cycles through 0, 1, 2, 0, 1, 2 as we travel down the number line. And we see that this creates a partition because we can take all the integers on the number line and sort them into 0, 1, or 2 mod 3. Now let's imagine that we take this number line and we sort of spiral it around itself so that all of the numbers that are 0 mod 3 kind of line up with each other, and same with the numbers that are 1 mod 3, that they kind of line up with each other, and the numbers that are 2 mod 3 as well. So we stack all of these numbers together and we like staple them together. Then we'll label each stack with a representative from that class. So all of the numbers that are 0 mod 3, we'll just call them all one thing, 0, and same with 1 and 2. This has a cool cyclic structure where if I try to count on the actual number line, I end up circling around this thing. Another interesting example of an equivalence relation comes from geometry. If you recall similar triangles, we'd say that two triangles are similar if they have the same angle measures and proportional side lengths. So for example, all 45, 45, 90 triangles are similar to each other, regardless of how big or small they are. And that set of 45, 45, 90 triangles forms an equivalence class under this relation, is similar to. And something cool here is that we'll have infinitely many equivalence classes, each with infinitely many triangles in it, some really big, some really small. Now here's a cool example from calculus. Let's say that two functions are equivalent if they have the same derivative. So for example, all of the functions whose derivative is 2x can go in an equivalence class together. It turns out that this is an equivalence relation, and each class represents all of the antiderivatives of a particular function. Alright, I'm pretty new to making videos like this, so thanks so much for watching. If you found this helpful, like, subscribe, and follow for more.